In this video, we'll be looking at how to prove triangles congruent using the angle-side-angle and angle-angle-side theorems. In the angle-side-angle theorem, abbreviated as ASA, triangles can be proven congruent when two angles and their included side are congruent to two angles and the included side of another triangle. So again, what we mean by included, just like when we had in the last time the two sides made the included angle, it was the one between them. The included side will be between these two angles. So A is congruent to angle E, and angle B is congruent to angle F. So the side length that is between those two angles is the included side. We wouldn't use a side that it was like AC because that's not between the two angles that we know are congruent. So because of this, we know that these two triangles ABC and EFD are congruent because of the angle-side-angle theorem. Our angle-angle-side theorem, or AAS, is when triangles can be proven congruent when the two angles and a non-included side are congruent to two angles and a non-included side of another. So this is where we now have angle A congruent to angle E, B is still congruent to angle F, but now the side that's congruent is not the included side. So we know enough that these two angles and this non-included side are congruent to one another. So these two triangles are congruent because of the angle-angle-side theorem. So angle-side-angle is when the angle between them, the side between them is congruent. So you can kind of think about it in that order that you read it, angle-side-angle. We see angle-side-angle, right, in order, angle-side-angle. Whereas in our angle-angle-side, we have one angle, another angle, and then a side. They're not read in the same order because the side is not included. So we go angle, angle, and then side. So just using the pictures to help us see this. So down below we have 4 images of potentially congruent triangles, and for each of them we want to say why they would be congruent if they are. So when I look at the first picture, I can see that this angle is congruent to this one, and these other two are congruent to each other. So I also have this side that is shared, and we always want to mark shared sides. Remember, shared sides are congruent to each other because of their reflexive property. So that would mean that we have an angle, the side in between, and then another angle, and that is enough to say that the angle-side-angle theorem makes these two triangles congruent. In 2, again, we have congruent angles, and we have one set of right angles actually. So even though these are right triangles, it's not necessarily going to be the hypotenuse-like theorem. This time I have 2 angles and a shared side. The shared side, or the included side, between the right angle and the non-right angle, those are both the sides that are congruent because of the reflexive property. So again, in that same order, we have the angle-side-angle theorem that makes these triangles congruent to one another. In number 3, this time we have one angle that's marked as congruent and one side that's marked as congruent. So we know nothing else about these sides. The only other thing we can see is that this angle, remember from way back when, would be vertical to the angle across from it. Whenever you have intersecting lines, the angle across from it has to be congruent to itself to that angle because of vertical angles. So if you recall our vertical angle theorem, remember the trick was to draw the V and the A stacked like this, and we can see that those would be congruent to each other. So that gives us that other angle that is congruent to one another. So now we have an angle, and a side that are congruent to another angle, and side. So these two triangles would be congruent because of the angle-angle-side theorem. The side that was congruent was not the included side between the two angles, so that's why it's not angle-side-angle. It's an unincluded side, which makes it an angle-angle-side congruence. In our last picture, we have these two sides that are marked as congruent. So this bottom side of this triangle is congruent to over here with the 2 tick marks. The left side of this first triangle is congruent to the top of the other one because of the 3 tick marks. But we don't know anything else. These triangles aren't overlapping at all, so we can't really use vertical angles like we did or any shared sides like we did above. So we don't know any other information to say about this last one. So there's not enough information here, so we can abbreviate that as NEI for not enough information. not congruent triangles because we don't know enough. If you were given a little bit more information, you might be able to come up with that, come up with a reason of why they're congruent, but in this given diagram, we don't know enough. So we're going to use these new theorems to help us do some proofs here. So again, we always want to mark up our diagrams to help us decide how we can prove that these triangles are congruent. So we'll use the given information and then anything else we can come up with from the picture to help us. So the first statement is that RD is congruent to AD. So that means that these two segments here can be marked as congruent. And that's our first reason, and that's just given. The second set of information that's given to us is that R and A, those two angles, are going to be congruent to each other. So I'm going to mark them in the diagram. And I'm going to fill that into my proof because it was the second reason was that it was given, so that's the second statement. The third reason that's given to us here is that the vertical angle theorem is being used. So we want to look in our picture and see where do we have vertical angles. Remember that they're across from intersecting lines. So that means that this angle would have to be congruent to this one. So we name it as angle FDR would be congruent to angle CDA. And that would be because of the vertical angle theorem. So now looking at our picture, why can we say that these two triangles are congruent? Well, we have two angles and the side in between them that's included that are congruent. So this would be because of the angle side angle theorem. In our next proof, it's given to us that AB is parallel to CD. So remember, that's those arrows on the lines here. We're also told that DA is parallel to BC. That one wasn't already marked, but since they're not parallel to the top and bottom, we have to use two arrows to mark those as being parallel to each other. So this should be reminding you of our angle pairs with parallel lines. BD in this case is like our transversal here cutting through those parallel lines. So we're going to use that to help us make some guesses and conclusions from our diagrams. So we're told that AB was parallel to CD and DA was parallel to BC, and that is just given. The next statement is that ABD, that angle A to B to D, so this one right here, is congruent to CDB. Well, why are we allowed to say that? We want to look at our picture and see, okay, well, we have a parallel line, and this transversal cutting through them. Those two angles are between the parallel lines and on opposite sides of the transversal, so that means that those two angles are allowed to be congruent because of the alternate interior angle theorem. The next reason is reflexive property, and we don't have a statement. Reflexive property means you're looking for shared sides. We can see that both triangles in this diagram are sharing the side BD. So I can say that the sides BD are congruent to each other because of the reflexive property. Now again, in our next statement, it's blank, but the reason given to us is alternate interior angle theorem. Well, we already used those two alternate interior angles, and we want to look at our other set of parallel lines here. So AD was parallel to BC, and DB is still that transversal. Well, I could have, I can't use the angles that we already marked, but I could mark another set of angles. So we've got this angle and this angle. They're in between the parallel lines and they're on opposite sides of the transversal. That means that those would have to be alternate interior angles. We're going to name them based on their vertices here. So it was this angle and this angle, so we're going to say that angle ADB is congruent to angle CBD. Those were alternate interior angles over the other set of parallel lines. So remember that these were given to us in the given statement here. So then our last step is to say that why these two triangles are congruent. Well, we have the reflexive property giving us that DB is congruent to itself. We've got CDB and ABD congruent to each other, and then ADB and DBC congruent to each other. So we have an angle, a side, and an angle, and the side is shared between those two angles. So the angle side angle theorem makes these two triangles congruent. In our next proof, we have that the segment OM is bisecting the angle LMN. LMN is this whole angle right here. If OM is bisecting it, remember that that cuts this angle into two congruent pieces. So that would mean that LMO, that angle, and angle NMO would have to be congruent to each other. So we're going to start filling in our proof here. We have that angle LOM and NOM, so that's this angle and this angle, are congruent. That was given. We were also told that OM is bisecting this angle LMN, which means these two upper angles are congruent to each other. So the reason those are congruent is because that was an angle bisector. So the statement we can make about that is that angle LMO must be congruent to angle NMO. That was using our definition of angle bisector. In the next line, we see that OM is congruent to OM. That's saying that something is congruent to itself, which is our reflexive property. And then we have the final statement that these two triangles are congruent to each other. Well, we have angles, sides, and angles, so two angles and a side. The side is that shared included side between the two angles, which means this is angle, side, angle theorem again. In our last proof, we were given that AB is parallel to CD, and that angle A is congruent to angle C. When we look here, we have AB is parallel to CD, and A and C are congruent. So those are given. Then we're going to look in our diagram. We can see that we have a reflexive property being stated in our proof. So we're looking for that shared side. I'm going to mark DB being congruent to itself. So right now we have an angle and a side. We're going to need another angle somewhere congruent in here. Well, we're told that these two lines are parallel to each other. So again, we're looking at this transversal that's cutting through parallel lines. That means that this angle would have to be congruent to this angle because they are alternate interior angles. So the alternate interior angles theorem would state that angle ABD would be congruent to angle CDB. Once we know those are congruent, then we can use that alternate interior angles theorem as the reason. We've already stated the reflexive property makes DB congruent to itself. So now we have an angle, and a side. The side this time is not the side that is included between the two congruent angles though. So the most we can say here is that the angle, side postulate here is the reason that these are two congruent triangles.